Microsoft recently published a paper in Nature demonstrating the creation of topological qubits, a milestone in quantum computing. Topological qubits, topological quantum computing, or Majorana-based qubits are theoretically more compact and could enable 1 million qubits in single system. But it's a theory, not any concrete public representation. Majorana qubits rely on topological superconductors which are extremely difficult to engineer. Unlike Google and IBM who have demonstrated working quantum computer, Microsoft has yet to prove a large-scale working prototype based on Majorana qubits. While Majorana qubits in theory should have low error rates, practical demonstrations are lacking. If Majorana 1 fails to deliver, it could cause a backlash similar to past overhyped quantum claims. So by the way, what is going on? Imagine a world where computers can crack impossible problems, simulate the entire universe, or design life-saving drugs in seconds. That just took a giant leap forward with Microsoft's Majorana 1, a revolutionary quantum processor that defies conventional computing. But what makes this chip so special? Unlike traditional quantum processors that struggle with stability, Majorana 1 uses an entirely new type of qubit, one based on Majorana particles, a theoretical entity that has eluded scientists for decades. Microsoft claims this is the missing piece to achieving scalable, fault-tolerant quantum computing. But is this a true breakthrough or just another step in a long journey? The problem with a traditional quantum computer. Before we dive into the Microsoft's Majorana 1, we need to understand why quantum computing has been so difficult to scale. First, error rates and decoherence. Quantum bits are extremely fragile. They lose information due to the decoherence, the slightest interference from heat. Electromagnetic fields or even cosmic rays can cause computational failure. Fault tolerance issue. Most quantum computers require millions of error-correcting qubits just to keep a handful of logical qubits stable. Scalability challenge. Google, IBM, and others have built peaceful quantum chips, but they still struggle to scale beyond a few hundred qubits without massive coolings and infrastructure. Enter the Majorana 1, Microsoft's bold attempt to solve all these problems at once. Hundreds of years ago, mathematicians Majorana predicted a new state of matter, the topological state, and since then the researchers have been looking for a very specific, very useful quasi-particle within it, the Majorana particle. Microsoft claims that they observed this last years and now they can control. These quasi-particles exist as a split electron pairs within specialized materials called topoconductor. Topoconductor, which is being by those Majorana particles, is a new type of semiconductor that operates also as a superconductor. With this material, they are building a whole new foundational architecture for quantum computing, a topological core, allowing this to scale not tens and hundreds of qubits on chip but millions. Unlike regular qubits which exist as either 0 or 1, Majorana qubits store information in a braided topological state, making them far more resistant to error. So why this revolutionary? Traditional quantum computers need massive error correction mechanism. Topological qubits self-corrected, reducing the need for extra qubits. Scalability. Majorana-based qubits are theoretically more compact and could enable 1 million qubits in a single system. Early tests suggest that quantum gates using Majorana particles can achieve error rates as low as 0.1%. A significant improvement over superconducting qubits. For comparison, Google Willow chip achieved quantum supremacy with 105 qubits but struggled with error correction. Microsoft's approach skips these problems by designing qubits that are intrinsically stable. If this technology works at a scale, it could leapfrog Google and IBM entirely. But there is a skepticism too. Like Majorana qubits rely on topological superconductors, which are extremely difficult to engineer. Unlike Google and IBM, who demonstrated working quantum computers, Microsoft has yet to prove a long-scale working prototype based on the Majorana qubits. And while Microsoft qubits in theory should have low error rates, practical demonstrations are lacking. So this is overall my review on this, guys. If you find useful, hit the like button and watch my past exposed videos. Thank you. Bye bye.